Wah, di film itu ikut-ikut berarti
Hello, Sreenivas.
Sir, good afternoon.
Good afternoon. Am I audible?
Yes, sir. Yes, sir. Good afternoon, sir.
Hello,
Namaste.
Sreenivas.
Sir. Sir, good afternoon.
Good afternoon. Am I audible?
Yes, sir. Yes, sir. Good afternoon, sir.
Oh, it is resounding, I think.
Resound వస్తుంది.
Sreenivas?
Sir.
No. That was the earlier call only.
Yeah.
Good afternoon. Am I audible?
Yes, sir. Yes, sir. Good afternoon, sir.
It is resounding, I think.
Resound వస్తుంది.
Sreenivas?
Sir, me, I have to post. Sir, in 2 minutes,
No
we'll
problem.
start, sir. Just one.
సార్ గుడ్ ఆఫ్టర్నూన్ సార్.
గుడ్ ఆఫ్టర్నూన్ రాజు, బాగున్నారా?
బాగున్నా సార్, మీరు బాగున్నారు సార్?
బాగున్నానండి.
సార్
So actually participants are about 50, sir.
Okay.
But as of now we have 20, 21. Shall we wait for 2-3 minutes, sir? Otherwise,
Sure. We'll wait for another
okay.
couple of minutes. No problem.
Okay, sir.
It's 2:18 now.
Sir.
Probably 2:20 or 2:25 will start off.
Okay, sir. Okay, sir. Thank you, sir. Ah. Sir, shall I start the program? Now it is 2:23.
Please start, please.
Okay, sir. Thank you, sir. Yeah. Good afternoon to one and all. A warm welcome to fourth day session of this online 1 week faculty development program on advancements in construction materials and practices. Now I take a privilege to welcome today's speaker, respected Professor P. Sreenivas Sharma sir. He is going to explain on developments in the fields of building construction and relocation. Before start the session, let me introduce the speaker. Professor P. Sreenivas Sharma sir is having teaching experience in technical education over 40 years. He had recently retired as professor from CBIT Hyderabad. During his working tenure, he has handled many administration posts in CBIT, such as head of the civil engineering department, vice principal, director student affairs and progression, advisor SA&P. Now he is currently working as advisor to campus constructions. Apart from this, he is honorary consultant, structural consultant to many construction firms in and around Hyderabad. He has delivered 51 expert lectures. He has published 45 technical papers in various journals and conferences, and also conducted 20 conferences and workshops. Regarding honors and awards, he won appreciation of Collector of Ahmedabad for the expert services rendered after the 26th January 2001 earthquake. He won the Best Teacher Award for Civil Engineering in CBIT. He is also the member of many professional bodies like IEI, ICI, ISTE, ISWE, etc. He edited 5 books and 1 book authored by him. Regarding his education, he completed his Master of Engineering, that is ME in Structural Engineering from Usmania University, Hyderabad in 1985, and BE in Civil Engineering from the same university in 1982. Sir, thank you very much, sir, for accepting our invitation. Now, I welcome you to proceed with the session. Dear participants, all the very best to all of you and happy learning.
Thank you, Sreenivas, for a lengthy introduction. And can I now?
Yes, sir. Now,
are you sharing the screen? Shall I share the screen?
Yes, sir. Yes, sir.
Am I authorized?
Yes, sir. We made you as co-host, sir.
Okay, just. Just give me some time, Sreenivas.
No problem, sir.
I'm just searching here.
At the bottom, sir, you have share option.
Yeah, that's right. But 1 second.
Before sharing that, sir, you have to open that PPT, sir.
Yeah. That's right.
Then it will be visible. First, open that PPT, sir.
Right. Yeah, but I'm not finding it. Yeah, right. Is it visible now?
Yes, sir. Please keep in slide show mode, sir.
Yeah. Is that right?
No, sir. Still all visible, sir. Not came into slideshow mode.
Here for me, it's showing. Slideshow only. See,
No, sir, it is not in slideshow mode now. All left side also all PPTs.
Sir, click on F5 button, sir.
that's what see I did. But anyway, once again,
Otherwise, you can go for slideshow, sir. On top of the row.
F5,
F5, sir, F5.
I'm doing that, but for me it is now coming as slideshow. But for you, it's not coming. For me, it is in the slideshow mode only.
Otherwise, refresh, sir.
Tell me.
Otherwise, refresh your screen.
Once again, shall I stop sharing and again?
Again.
Yeah. Or keeping it in slideshow and then that can I do? No, I don't think so. Right. Now, you are able to see the...
Yes, sir. We are able to see your PPT, but not in slideshow mode.
Now, just... see, again, I'm... Now? For me, it is showing slideshow.
Sir, no problem, sir. Otherwise, continue, sir.
Oh, Bobby. Or shall I join through another laptop and then at least that you will see?
No problem, sir. Like this also, no problem. Please go ahead, sir. No problem.
Okay. No problem, huh?
No problem, sir.
Friends, bear with me. It seems to be there is some technical issue. Anyway, for me, it is showing in slideshow mode.
Okay.
Yeah, today's hosts, GRIET management and staff, and in particular, my beloved students, Dr. Sreenivas, he was my student, and Dr. Raju, they were my students. And probably that is one of the reasons why they have invited me. So thank you all for inviting me. I treat it more as a learning experience for me because I'm an old timer, but still you must have heard of so many other new developments. So my context of dealing with this topic today is that the building construction must suit the common man, ordinary man. They must quench the thirst of building construction in common man also. So in that direction, just I'm trying to put forth my thoughts, not that there is anything big new things in this, but still let me try to go through this. So we'll just try to review how the building construction evolved. There were some revolutions that impacted the evolution, and some modern materials, technologies, including sustainable materials and technologies, we'll try to recollect. And then there is another context, relocation of buildings, which I thought that is the different thing that I'm going to talk about in today's thing. So what are the modern trends, and then how to conclude? So we are going to redefine building construction and relocation at the end of that. So that is the plan. Let us see how it works out. So as you all know, civilizations, different civilizations.
Sir, sorry to disturb you. Still, we are in the first slide only, sir. First slide only visible to us.
Then let me just take the help of another. See, I have two laptops. One,
Okay.
in one, audio is not there. So
Yeah.
I'll use that for video.
Okay.
And I'll still use, let me just play video.
Okay, sir.
Okay, please. Just give me some time, couple of minutes.
Okay, sir. Okay.
నేను ఒక 5 నిమిషాలు వాళ్ళందరికీ చెప్పేసిన తర్వాత మాట్లాడదాం లాస్ట్ మోహన్ ఆయమ్మకి చెప్పి కొంచెం నీళ్లు తాపించండి ఉంటే ఒకవేళ ఆయమ్మ కొంచెం వాటర్ తీసుకురమ్మ. బాటిల్ కొంచెం కడగమ్మ.
Srinivas, I'm joining through other laptop.
Okay, sir. Okay.
Take time. So meanwhile, as it works out, it's taking a little time. For me, it is changing. The slides are changing, but
Your voice is very clear, sir. Voice is very clear, but if net problem is there, voice is also not coming actually.
that's what I'm.
Your voice is very clear.
But here, for me, the slides are changing.
Okay.
Open Zoom meetings. This is saying some. Your app version needs to be 5.15.5 or higher to join this meeting. Shall I say join from browser?
Sir, otherwise, could you share the PPT to me, sir? I will share the PPT.
Yeah, that will be better, no?
Best, sir. Then you share to me, sir. I will share here.
Yeah, here now it's joining.
Send through WhatsApp, sir, so that
But it
I will
is-
download it and I will share it, sir.
Okay. Meeting passcode it is asking in the other laptop.
Meeting password I sent you, no, sir. Just all are once only, sir. Meeting password.
All once, huh?
Sir.
Let me just see.
Just see, sir. I've sent you already. Password, meeting ID password.
111111. Okay.
6 ones.
Okay. That is meeting passcode and your name.
Sir. Sir, meanwhile, you send that PPT to me, sir, so that if any
Yeah,
problem comes
I'm
again,
sending. I'm
I
sending.
will be ready.
Just check if this is. Am I joining? Yeah, I have joined already.
Okay. And which name, sir? Same name, This one also?
Srinivas Sarma P.
Sreenivas Sharma P, it is there already.
Another one. Shall I change the name otherwise?
Other also same name, sir.
Same name. See,
Sreenivas Sharma came, sir. Yes, I am making this as go, sir, so that.
yeah. Please do that and let me see.
Sreenivas Sharma came, sir. P not there, sir, for this one. First
Okay,
one
okay.
P is there.
Okay.
And now I made his course, sir.
All right. So I will do one thing. I will open this. All right. Now.
Here your audio option is not coming in this.
Yeah, audio is not there. For
Yes,
this.
sir. Okay.
That's the reason I opted for new laptop.
Okay, sir.
But anyway,
Okay.
share.
So here you close, sir, first.
Huh?
The first one you close.
First one, shall I close?
Stop sharing in the first one, then
right.
start there.
Okay.
Yes, sir. Now you start there.
Is it coming? 1 second. 1 second. Let me again do that. 1 second, just. Entire screen. Yeah. Yeah, now
Yes, sir. Now keep in slideshow mode, sir.
I've done that.
So
I've
go
done
to
that.
second page, sir.
I'm going, but
No, still same, sir. In first slide only still.
see, I've been changing the slides. What's the problem?
Still in first slide only, sir. Otherwise, send that PPT to me, sir. I will share it.
Yeah, better, please. Huh? Sorry for the trouble. I don't know
No
why.
problem, sir.
I'm sending it, right? Right.
Sir. In WhatsApp, sir. Otherwise, mail, sir. You do mail, no problem.
Please send your mail ID.
Sir.
In WhatsApp, you keep. Yeah. Yeah. Tell me your mail ID. Otherwise.
Srinu.tummala, sir. SRINU.
Yeah. Yes, right.
NU dot tummala. TUMMALA.
TU.
Yes, sir. @gmail.com.
Yeah. Please check.
1 minute, sir.
Actually, if caps lock is pressed, it will not come, huh?
Which one, sir? Even sharing, sir?
షేరింగ్ క్యాప్స్ లాక్ ఉంటే అది రాదా ఏమన్నా అట్లా ఏమైనా ఉందా?
అదేముండదు, సార్.
సరే మీకు పంపించాలి చూడండి ఆల్రెడీ.
Yes, sir. Just now came, sir.
Okay.
I'm downloading. Sir, is it visible to you, sir, now?
No, it's visible, right.
Sir, I kept in now slideshow mode.
Yeah.
Is it visible, sir?
It is.
Okay, sir.
Right. Now go on. Now let us save some time by quickly rushing through next slide.
Okay, sir.
So the evolution we'll try to recollect quickly through Neolithic age, Indus Valley civilization, Egyptian civilization, Mesopotamian, Greek and Roman civilizations. Next. So if you see the Neolithic age, all stone culture was there at that time. That was before 3000 BC. Next, please. And later on, Harappa, Mohenjo-daro, Indus Valley civilization. Of course, Mohenjo-daro is in Pakistan. But this Harappa is there. You can see the brick-like things, mud bricks or clay bricks. They started that kind of culture. Next, please. Mohenjo-daro. This is again similar kind of thing. They both belong to 3000 BC. Next, please. Then 3000 to 300 BC, the dominance of Egyptian civilization you can see, including the pyramids construction and all that. Next, please. And 2nd century AD, during that season, mud buildings, Multi-storied buildings also were constructed. They are still standing. They are treated as endangered species in building construction these days, so something has to be done. In the Middle East, it is there. Next, please. So the Pueblo Indian multi-story houses, they are called. That kind of culture is still there. Next, please. Then Mesopotamian, mostly the adobe kind of things, mud bricks and all that. 3rd to 7th century AD. Next, please. So, of course, Greek and Roman civilizations are there. We will again recollect them later on. But basically, the revolutions that impacted. Renaissance was a cultural revolution, basically. So there were cultural changes. Along with cultures, the shelters also changed. And industrial revolution was there, in which wheel and such things were invented, and therefore transportation was easy. Mechanical advantage was taken up, and that continued up to 18th to 19th century. Later on, we have witnessed tremendous IT revolutions where the IT, information technology gathering, was there. And then nanotechnology. With the advent of nanotechnology, some newer things have revolutionized the field of construction also. So we'll try to rush through these kinds of impacts of these revolutions in the next slides. Next, please. So basically, the evolution, that came from the need of protecting human being from weather and animals, or probably as the time passed on, their awareness increased, needs increased, and also the inquisitive nature, the exploration attitude has increased, testing and inferences of applications. So research inferences came up. And also we have learned lessons from natural disasters. So all these have contributed for the evolution of shelters. Next, please. So early man used to live in caves. Next. Then mud houses, stone houses. Next, please. Masonry houses, RCC houses. Then came, of course, steel. Steel, again, if you observe, these days, again, in Hyderabad also, many steel structures are coming up. So the styles and forms of shelters, there is a relation between material and form, and natural structures and their configurations, traditional styles versus vernacular styles. All these were studied by a man, Vitruvius, an Italian architect. So we'll also collect something about that. If you take the materials, material-wise, there are 300,000 of materials. Metals, ceramics, semiconductors, polymers, composites, biomaterials, exotic and strange materials are available. And although they are there, but stone, mud, wood are still being used. And in addition to that, some derived materials, burnt bricks, mud bricks, clay bricks, lime, cement, mortar, concrete, iron, steel, RCC, and now fiber has come. So FRP plastics have been used now. So these are the materials. Next, please. Yeah. Materials and methods. If you see 3500 BC back, bricks were there. Almost. I mean that some people say that 3500 is Mahabharata. So probably from that stage onwards, this mud bricks were there. Next, please. Then baked mud bricks, adobes, kinds of things were there in Egyptian culture. Next, please. Yeah, ancient Greeks used, now here Roman and Greek culture, we'll try to recollect something. So beam and post kind of construction was there. They have used that first. And they also constructed arch kind of configurations. Arch bridges were used, arches were used in buildings also. Then domes have come up in Romans, Parthians and Parthenons, if you see that, those kind of buildings, prayer halls, etc. They have used. And in this, they have used some stone chips or brick pieces and blended with some kind of mortar. So that itself they used to call concrete in those days. Next, please. So in the medieval era, forts, castles, cathedrals, these were constructed, and most of the buildings in North Europe, they were built in timber also. So timber also came into picture then. Next, please. So material-wise, culture-wise, we are trying to recollect. And Renaissance in Italy has changed the character of the building. Vitruvius, the architect, he has, in the beginning, he was the first person to look into the relation between form of the building, material, its strength and all that. Next, please. Yeah. So this man, Vitruvian, both names are in usage. Roman architect he was. He said that there is a relation between beauty and delight. There is a relation between durability and firmness. There is a relation between convenience and service. So all these relations he has studied thoroughly. Next, please. So one is, this is triangular representation and tetrahedral representation. Firmness, service, and delight, they are interlinked, he said first. Later on, he has linked it up to economy also. Firmness, service, delight, and it, construction, operation, and maintenance costs also he has included. So that kind of thinking went on, and building construction was including, particularly in Italian context, these 4 parameters. Next, please. Then materiality also was included. It has become a tetrahedral representation of materiality. Later on, octangular representation, delight, shape, service, firmness, materials, economy, dimensioning and detailing, and constructive technologies. All these are imbibed. And at the present stage, this is what is. But in addition to that, now sustainability, another catchword has come, including green building nature, eco-friendly nature, user-friendly nature. All these are the catchwords these days. So it is more than an octangular description now. So the challenges for future are, we are now noting that natural resources are being depleted, needs are growing, social, cultural, professional needs, increasing disasters are there. So from national to international and global to global picture is coming up. So people are thinking of shifting even to other planets also. I think there were announcements in about 4 or 5 years back that those who are ready to be transported to Jupiter, somebody is facilitating that. So these kind of thoughts are coming up at least. Next, please. So materials wise, if you see, there are newer materials coming up for concrete, eco-friendly materials, lightweight materials, smart materials and structures, nanotechnology and nanomaterials have come. Sustainable materials are the catchword these days. Next, please. Special concretes, if you see, high strength concretes, self-consolidations, SFRC, SIFCON, slurry infiltrated fiber concretes, polymer modified concretes, polymer impregnated concretes, bendable concretes, transparent concretes, all these have come and they are being used. In addition to that, nanotechnologies has come up. Next, please. For it is finding some applications in civil engineering. And with the advent of nanotechnology, now construction field is also no exception. They are also using the advantage of nanomaterials. Next, please. Construction and health monitoring aspects, that's where the interfaces are there in structural engineering and civil engineering. Next, please. There is a material called nano muscles. It's kind of shape memory alloy. So nano muscles are known for their lighter weight but greater strength. Next, please. So an advantage of this new shape memory alloy is its efficiency. No other alloy or polymer can nanopolymers can be compared with nanopolymers in terms of its strength and efficiency to weight ratio. When a building is constructed these days, we are looking out for strength to weight ratio. So nano muscles, if they are blended properly, then 1 gram of nano muscle can lift 140 grams. That is the advantage with these nano muscles. So people are using these nano muscles judiciously. Next, please. Then we are marching towards sustainable construction. Sustainable means development that meets the needs of the present without compromising the ability of the future generations to meet their own needs. So we must go on with our inventions, but we must still keep challenge for the future generations to accept and find out their own newer things. That is the idea of sustainable development. Next, please. A truly sustainable development, whether it is any field you take, building construction is the field we are talking about. It must link up micro to macro, present to future, human to nature, material to spiritual. In building construction, we have been, we have been using glass facades and all that, and the inner environment is disturbed, and it is in fact contributing to global warming also. So sustainable development puts economic growth in the framework of lasting human happiness. So both are to be balanced. Next, please. So we must meet the human needs, but we must maintain ecological integrity, social sufficiency, and social equity. Next, please. So these are the ingredients of sustainable construction. Only when the financial investments are balanced, materials are taken care, tools are taken care, technologies are taken care. If any one of these is collapsing, the system collapses. So sustainable construction of buildings must take care of all these. Next, please. Sreenivas. Yeah. The problem with Indian context, if you see 70% of the country lives in rural areas, 2/3 of the country's geographic area is disaster prone. So our building construction must focus on, disaster resistant constructions. Okay. That is another point we would like to add in our building construction. Next, please. And another thing is, whatever we do, we must give advantage to the rural areas because 2/3 or 70% is rural. Now, out of this 70% area, disaster prone area, 57% are hit by earthquakes, 8% is hit by cyclones, 5% by floods. That means our buildings, whatever we do, must be mostly seismic resistant. Other things, of course, follow. If you see these areas, how much area is prone to earthquakes, how much area is prone to floods and all that is given here. Accordingly, our building construction must go. Next, please. Yeah. About 6 lakh, that has increased now. This is about a few years back. So about 6.5 lakhs to 7 lakh villages, 11 million houses are still required. And 40% do not have kitchens, 70% do not have toilets. So building construction at large, if you see, mostly that should focus on rural buildings is what I wanted to project. Next, please. Various schemes are there, but Pura is one scheme proposed by our Dr. APJ Abdul Kalam, providing urban amenities for rural areas. One of the main reasons for why the rural people are migrating to urban areas is that they do not have proper facilities. So Abdul Kalam ji thought that if we provide urban amenities in rural areas, probably this kind of too much of migration to urban areas can be arrested. So our building construction must also take care of these things, providing urban amenities in rural areas. Next, please. So these are the objectives of Pura area. Next, Pura scheme. Next, please. So the building construction in the government sector has been focusing on number of houses. I mean, quantitative aspect rather than qualitative aspect. So they mainly focus on the shelter. To these many lakhs of people or crores of people, we have provided shelter. That is what the building construction is focusing. But whereas it should have focused on quality aspect, the living conditions aspect. Next, please. Localized materials like bamboo can be used for as a sustainable material and for earthquake resistance also. We have tested in our labs and numerical studies also we have made. It is seen that bamboo is a very good sustainable material. Next, please. So, introduce disaster-resistant technologies in a demystified, non-alienating, and people-friendly manner. That is what is to be done in building construction. Next, please. Another important, although I could not gather much more, although I have worked in this area, anchoring technology has revolutionized the building construction these days. Without disturbing the existing structure, expansions can be done, or even retrofitting of a column or footing can be done by just anchoring the bars. So very good anchoring technologies have come these days, and one must make use of anchoring technology in building construction. It is needless to say that, it is highly revolutionary in terms of retrofitting of buildings also. Next, please. Steel structures, when we talk of steel structures, from 19th century, Bessemer process whenever has come, steel production has increased, and therefore steel being used from that century onwards. But because of its greatest disadvantage of corrosion, its usage was decreased in the earlier century. But this century, if you see, steel constructions have again come back. Pre-engineered constructions have come back. So buildings are using steel constructions. Next, please. Next, please. Yeah. In the 20th century, the development of new steel alloys and fabrication techniques further enhanced the strength and versatility. Structural steel shapes have come. Welding technologies have come. So cost-effective construction methods also have been invented in steel field. Next, please. Next, please. Recycled steel construction is also taking place. And computer-aided design, building information systems, building information modeling has also come. And with the advent of these, the incorporation of smarter technologies in steel. These days in Hyderabad also we are seeing frame is built in steel and remaining things are built in concrete. Like that, the hybrid models also we are taking up. Next, please. And in steel, not only in steel, this has come in concrete also. Advanced composite materials have come. Smart and responsive steel structures have come. 3D printing techniques, which I am going to again discuss, has come in steel structures also. Next, please. There is what is known as energy modeling software, which can simulate, which can simulate, the inner environment, energy usage based on the design, orientation of the building, materials used, and operating systems. So, based on the inner environment, it can be managed. Retrofitting means not necessarily structural retrofitting. Inner environment also can be retrofitted in a building. That is another catchword. Next, please. So, self-healing steels have come, as we have seen. Self-healing concretes, self-healing steels have come. This is one thing. And energy harvesting efficiency is increased in the future steel constructions. Multifunctional steel structures have come. I mean, built-in transportation systems are there. A building could have bridges, transportation systems, and also it could house residential purpose also. So, bicycle lanes could be there in the buildings. Next, please. Modular and adaptable designs have come in steel structures. Robotics and automation has also encompassed in steel constructions. Next, please. Shape memory alloys, which are very important, particularly in the context of earthquake, seismic retrofitting of buildings. That means what happens when you use shape memory alloys in buildings, the building gets deformed. Later on, after the forces are removed, the building again recollects its shape and comes back to original shape. So shape memory effects have been invented in 1941. And since 1960s also, the usage of shape memory alloys is there in the buildings. Next, please. Yeah. Shape memory alloys are used in masonry structures, masonry walls. This is how these shape memory alloy strands, these strands, they are useful in again bringing back the masonry wall to the normal position. Next, please. So what you could do is you could introduce prescribed pretension in the shape memory alloy strands, and therefore it comes back. So it is observed that the hysteresis loop of the hyperelastic stress strain, diagrams, relationships, it dissipates more energy if you use SMAs in masonry structures. Next, please. This is the kind, but it depends how you use those shape memory strands. This is vertical at a greater spacing, at a closer spacing. All these were experimented and numerically studied, and therefore, see, with different kinds of strips. So obviously, as the spacing is decreased, these devices will work out better. Next, please. If you see a result of one study here, stiffness increased by 98.1% with vertical strips. And then in the cross strips, stiffness increased by 127.9%. That means the swaying or drifting of the walls, diagonal cross strips means this cross strips. So that will help us more. So that way you can see stiffness has increased by 127.9%, right? So if you see the maximum resistance was 108 kilonewtons, while in the end cycle it reduced by almost half and reached by 40 kilonewtons. So larger deformations, the greater the scattering of the iron-based strips, the more resistance the masonry wall is. Thus, that means maximum advantage is taken up because it is a kind of under-reinforced masonry structure. So it's not that you're going on making it more stiff. That also is not good. Next, please. In terms of dissipation of energy, which is more important in the earthquake resistant structures context, cross strips were proving better. The hysteresis loops were showing more of flattened nature in their curves. So the greater the dispersion of SMA strips on the brick wall, the greater is the energy dissipation. This is what was observed. Next, please. Another revolutionary thing is in situ retrofitting using additive manufacturing with mobile robots. So what they do? They use the artificial intelligence concepts and machine learning algorithms they use, and that's how they were integrated in robots. And then these robots will picture and memorize the total shape of the building or a structural element, whatever. Let us say a wall is to be built. Then it will remember the total shape and it goes on adding. So the this was used in mechanical field basically for additive manufacturing. Same concept we can use in civil engineering also. So they go on adding until the total shape is finished. So this is called additive manufacturing concept, and robots were given these algorithms and they go on building. No labor is required for this. Next, please. This is 3D printing technique. So 3D printing technique, one second, get back that. So 3D printers you must have heard, it takes number of pictures of the entire structure. It was used in medical field also. If you want to operate the brain, number of sections through the brain, longitudinal, transverse, all sections it will take. And it will give you the total picture of what it has got to be. Similarly, if a building is to be prepared, building all elements, that 3D printer, it takes all the shapes and it goes on building it in layers. But the main disadvantage is that 3D printers of smaller sizes only are available as of now. So it can't, produce that concrete as of now. There are bigger printers also here and there, but they are very scattered, very less in number. In IIT Hyderabad also we have one 3D printer, wherein in CBIT also we have a 3D printer, wherein only mortar we can use. So any elements that can be built by mortar can be done as of now. For bigger thing, it is still costly. It remains to be costly. But only thing is mass operation is there, then that can be marketed also. So what we can do is the layer-wise printing, the 3D printer can be equipped in a robo, and 3D printing technology can be carried out with the help of robots. Next, please. Building physics is another area which mainly focuses on moisture, inner environment, heat transfer, radiation, acoustics, all these aspects. There is one good book by Ajita Simha, I think, Building Environment. So building environment is also equally important when we talk of building construction. So building physics is made use of for retrofitting technologies. When I say retrofitting, as I said earlier, it's not just dealing with the structure, but the inner environment also. Next, please. Thermal imaging, infrared cameras have come these days. Now, they can be used to picture, visualize where the heat is escaping out, or where the heat is flowing into the building, or where dampness, even dampness can be picturized with these cameras. So moisture contents, etc., can be picturized with this, and we can play with the inner environment of the building. That way, the thermal performance of the building can be really modeled using this thermal imaging technology. Next, please. Moisture detecting technology has also come, and same thing, we can use even thermal infrared cameras or hygrometers and moisture meters have come, so we can measure them and we can identify the potential issues. So which area, which part of the building is subjected to, is more prone to moisture and all that can be identified. Next, please. Sreenivas.
Sir, I move to next slide, sir. Building information modeling.
Oh, for me, it is stuck up again. Okay, let me see. No problem. I will. Okay.
Sir, I am in building information modeling slide.
Okay. Same. That slide is there. Right. Okay. It has moved now. Right. Okay. So building information modeling. This is again another area these days. Many people are using this software. It gives a digital representation of the physical and functional characteristics of a building. That means including minute aspects, components of a building, not only physical, whether it is functioning or not. So it gives a total idea. So this helps us more for the maintenance aspects of the building. Whenever we say a building life cycle depends on its maintenance also. So maintenance aspects are very much looked after by this BIM software, and thus it also helps us in taking policy decisions on retrofitting measures and all that. So it could be a very resourceful software which gives information about all components of the buildings, materials of the buildings, smaller, minutest screws, fastenings also. Everything you can keep track of, and thus it gives a idea. It gives an idea about the life cycle of the building, right? You can take decisions on and you can also take decisions of retrofitting of buildings. Next, please.
Same data. Third year, let it be.
It's did you move?
Energy modeling software now.
Now it has come. It's a bit slow. I don't know why. Yeah. So the energy, a building energy is based on the materials used, its orientation, its operational systems, and all that. So these days we are looking at zero energy building, net zero buildings we are talking of, particularly in the context of green buildings and all that. So that is the aim these days. So to model the energy, how much of energy is incurred in building, let us say a flat or a multi-storied building like that, you can always calculate and control it, monitor it. So this kind of software, they can model how different retrofitting measures will impact the building's energy performance. Therefore, what appropriate step can be taken in retrofitting the building. Next, please. It's taking time. Okay. I'll be ready here.
So here also not coming, sir. Actually, I am pressing this one, but not coming.
Asha, for you also?
Sir.
Let me say then.
Sir. Now change, sir.
Smart sensors and IoT. Yeah, Internet of Things. And that also has been incorporated in buildings. Based on this, various parameters like temperature, humidity, light levels, occupancy can be checked, and energy use can be checked. Who is using in which room, how many fans are running, all these can be checked, or ACs are running, all these can be checked. So this data can be used to optimize the building operations for energy efficiency and comfort. So smart sensors have come basically. Next, please. Incorporation of smart sensors and IoT. And then, yeah, AI and machine learning algorithms have come. So as I told you, they can be incorporated in robots, and we can make predictions and recommendations for optimizing the building performance. So like, building is treated as a performing element now. Earlier, it is treated as a stagnant, a stationary one. But no, building and its environment, along with its environment, is treated as a dynamic element, and therefore, time to time, its inner environment also is to be tested. Just 1 second, Sreenivas. There is another.
Okay, sir. Okay. Sir.
Sorry, Sreenivas.
Okay, sir. No problem, sir.
So AI, artificial intelligence, and machine learning concepts have come. One must, understand that additive manufacturing is a subset of artificial intelligence, and machine learning is a subset of artificial intelligence. So artificial intelligence, neural networks, all these, neural networks suggests us an algorithm, So in neural networks, and again, there are biological algorithms are there, so to simulate. So all these are being incorporated. Now the catchwords are, everybody is taking up these days only AI, ML or something like that, data science is like that. But being in civil engineering also, you can come in touch, leaving old timers like me, but you people, youngsters, can come in touch with these kind of concepts, how they can be applied to our fields. If you catch up that is the pulse of today. So you need not shift to other fields, please. Tremendous potential is there in civil engineering, but only when you keep abreast with these latest technologies and software and tools. Then please, next please. Yeah. Simulation softwares have come. What are simulation softwares? You can, create a building environment, physical environment and inner environment, and how it behaves. So simulation can be done. Like these days, concrete cube testing need not be done. All ingredients, if you incorporate in the software, and loading rate and all that, if you manage, and how the cracks will occur, you can always know. Similarly, a building also can be created with all the ingredients properly incorporated into it and can be tested. Simulation software helps us in testing the virtual models of buildings, and therefore you can observe various scenarios. There is no need to, in structural engineering research center, huge shake tables are there, huge experimental modeling and testing facilities are there. All that may go off in the coming years. Next, please. Yeah, particularly these already we have talked of. Next, please. Modern methods of construction, if you talk of, leaving those tools and softwares and all that, mainly, as in today, what are in vogue? Prefabricated construction is one thing. And then green building technologies is one thing. 3D printing, volumetric constructions, 3D incorporation is one thing. And another thing is, mostly all these have come, modular construction, prefabricated construction, they go together. But mostly all these have come because of one important thing, farm work. There are radical changes in farm work. So massive constructions, we are using farm work as a big resourceful tool to go in for modern constructions. That way, the last one, the tunnel form work or the thin joint block work, this is called, that is being very explicitly used in the modern constructions. Most of the multi-storied buildings these days are being constructed using tunnel form works. A particular stretch of a building is constructed like that. And prefabricated staircases have come. So directly you are transporting and keeping them there. That's it. So this helps us. This kind of modular and prefabricated construction saves a lot of time. And because it is cast off the site, accuracy can be maintained and brought into the field, and then it can be arranged. Of course, there are customized practices wherein on the site, if the site is very voluminous and a lot of huge construction is going on, there itself the precasting yard can be kept. Next, please. Yeah, these are the systems and technologies. Next, please. Yeah. So here, just go to the next slide, please. You can construct anything. This is the kind of, so you cast them in some yard, bring them here, just arrange them. This kind of precast construction is going on, and it will be tailored out to suit the geometry of the building and need of the client. Next, please. It is faster, it improves quality, it reduces waste, it enhances safety, and there is design flexibility is there in that. People think that these kind of prefabricated and modular constructions, we may not have flexibility, but you have a lot of flexibility. If you want to change, remove that panel and bring another panel. I mean, that kind of flexibility is there in this. So that kind of technology is developed. If you want to see in IIT Hyderabad, most of the quarters, most of the multi-storied buildings also they are constructing in that campus. Still it's going on. You can visit that campus. Next, please. Drawbacks. See, transportational cost is heavy. Limited site adaptability. You may not be having that much of space in the casting yard space in the site. Therefore, site adaptability could be less. And you have to plan upfront several days before only. A small door is coming somewhere, window is coming somewhere, corner is coming somewhere, joints are coming somewhere. All these to be thought of a priori well before and planned, and so that assembly becomes easy. But initial investment is heavy. Therefore, only for larger constructions, this can be suggested. Next, please. 3D printing. The entire houses can be printed. There are two companies, Icon and Apiscor, which have successfully 3D printed entire houses using large scale 3D printers. They have them now. Very few companies in India, as far as my knowledge goes, have this. And 3D printers to print concrete components also are there, which are very sparsely distributed across the country. So it's not that common as of now, to my knowledge. Next, please. Yeah. This is also 3D printing. Rapid construction, customization can be done. Resource efficiency will be there because additive manufacturing can minimize material wastage. And cost savings, sustainability. It is projected that 3D printing is the order of the day and it is going to sustain for the years to come. That is what they project. And it appears so. If 3D printers which can print any kind of material, if they are made common, then probably that is possible. Next, please. There are some drawbacks, scale limitations are there because machine limitations are there right now. And material constraints are there right now. I will say right now. Regulatory challenges, 3D printing construction is a relatively new technique. Therefore, what kind of regulatory rules and hurdles will come? Building codes have to be changed accordingly. We do not know all this. So that is to be addressed. Technical expertise on 3D printers as of now is limited. So probably that would come. Next, please. India's first 3D printed house. It's actually a large scale, this building description is given here. I think I have the photograph also. Yeah. Twasta's official blog states that a standard 3D printer can produce 2,000 square feet home in less than a week. So total home. So which is 1/8 of the total time spent today in erecting a functioning house. So this is what they project as of now. Next, please. This is a first 3D printed post office, Cambridge layout, Halasuru area, Bangalore. This is. Next, please. Green building technologies is another catchword. You know, a green building is a green means, basically safe, which has got a safer environment, right? So when we say that safer environment in all aspects, structurally, inner environment wise, energy efficiency wise, all are incorporated in that. And these technologies aim to promote sustainability and reduce consumption of natural resources in the construction and operation of buildings. Therefore, next please. Yeah, this kind of thing. So the energy that is required for the building is produced by itself. So that is towards a net zero, so zero energy building. This kind of environment they are creating. In Hyderabad, there are few buildings like that, including the Gokaraju building. Next, please. Reduced environmental footprint, energy savings, healthier indoor environment. That is what? Green is more focused on this. Healthier indoor environment, enhanced market value, enhanced market value, sustainable image is there for green buildings. Next, please. There are some drawbacks like higher initial costs, limited awareness, regulatory complexities are there still. There are different regulatory authorities in this. Which one to be taken up is yet to be confined. Technological advancements, they become obsolete. The technologies what we are using today may become obsolete in no time. So that is another setback as of now. Next, please. Then smart building systems, which use smart components. Smart means what do you mean by smart? Smart and intelligent, there is a difference. We'll say our student, one of the students is very smart. What do you mean by that? It's not about handsome or being beautiful or anything like that. Smart means which acts on its own, doesn't take anybody's help. On its own, according to the situation, it acts. So like that, there are smart window panels, glass facades, they themselves produce solar energy, those kind of smart things. Or let us say, in a building, when an earthquake comes, it itself gives an alarm. So the building is smart. So like that, a material which acts on its own to the critical situation that arises instantly. So that is smart. Next, please. So smart building systems are towards energy efficiency, improved comfort and productivity, predictive maintenance, predicting something, some disaster in the forefront, then maintaining it. So this kind of predictive maintenance can be incorporated in smart building systems. Data-driven decision making. There will be nobody there, but it takes a decision on its own and sirens the alarm, let us say, something like that. So sustainability and green building concepts can also be incorporated in smart building systems. Next, please. Cost, complexity, and cyber security risks are there because most of these buildings are based on cybernetics, the computer-oriented logical programs and all that. Therefore, there is a risk of cyber security. Next, please. There is another bigger revolutionary technology that has come up, and this is MIVAN technology. MIVAN means it's a brand name basically, but if you explore the Sanskrit name, it is energy efficient, or it is something related to energy filled, something like that. Okay. So when you talk of such a word, that means that the building which is going to be prepared by MIVAN technology, basically this is also based on formwork. It is aluminum formwork. So which is very light, very flexible. And instead of, see, the difference between precast building and this building is that formwork is totally erected for the entire building using fastenings, the components, all columns, beams, everything. Formwork is totally erected and it is concreted. Once when you remove this, very nice, with a nice finish, the building is ready. So this kind of technology is getting popularized these days. Most of the buildings, my own students, big contractors, they are using these technologies. So If somebody wants to see in Chautuppal, there is a very big industrial area which they are producing this Mevan formworks also. Aluminum formwork basically. Next, please. You can see the entire building at once. So it saves a lot of time. But initial investment is high. Okay. But if everything is finalized, the plans are finalized, openings are finalized, everything is finalized, you can go in for this. Next, please. So this is the history, and more than 30,000 square meters of formwork used in the world are under their operation. In Mumbai, number of buildings are being constructed using Mevan technology. And extensively, this technology is being used in Europe, Gulf countries, Asia. In Hyderabad also, it is gaining popularity. Okay. Yeah, a time saving, a lot of time saving will be there. And walls and slabs in one continuous pour of concrete. Everything. Next, please. So, when mass housing is needed, when the number of repetitions are there, same formwork can be used for 250 to 300 repetitions without any problem. It is tested. So that is the typical floors. Even if typical floors are there, accordingly, different floor plans can be accommodated. High quality. Columnless structure can be arrived at. Of course, if you insist on columns, you can go in for that. But columnless structures can be, because everything in concrete, probably reinforced concrete walls can be incorporated in this. Next, please. This is a kind of formwork assembly. Not here, I'm sorry. Next, please. Deck and all these, of course, beam assembly. Next, please. Not clear. And then next, please. Yeah, these are beam components. There are different components prepared. Next, please. Deck components. Other components like, corners, internal corner, external corner, internal soffit corner, external soffit corner, like that. Okay. Next, wall panels, rockers, kickers, like that. All components, they'll be fastened. In normal traditional building construction, we have a 10-day cycle. Minimum is 10 days. Actually, two week cycles will be there. But in 4 days, the entire thing can be, you can see this is day one. Day one, setting out and survey and wall rebars, etc. Must be tied up. In 10 hours, it may take. Then striking the formworks for walls, and then erect the wall forms, strike the deck forms. So this is day 2. Day 3 is deck forms, like that. Day 4 is checking, and if there are any sunkens and spacers are there, deck rebars, all those. And of course, pouring concrete, it could take about 8 hours from then. So in a 4-day cycle, the entire thing can be completed if everything is well planned. Next, please. So like that, activities. Next, please. Speed of construction. This is the speed of construction, but entire thing can be done in 4 days, up to pouring of concrete. Next, please. See here you can see this is for Mevan formwork system. This is traditional formwork system, and surface finish, excellent finish you will get. This will be very bad normally, and you have to again finish it with plaster and all that, which is not needed here. It has got good resistance to earthquakes, less than olive forms, and then 250 to 300 repetitions are possible, whereas only 50 repetitions are possible here. So this is a kind of cast in situ cellular construction. It can be. Okay, but this is framed construction, normally RCC construction, cast in situ, that is also. This is different that way from prefabricated construction, which is not cast in situ. Right, next please. So if you compare, it's very good. It's proving to be very good. Therefore, it is getting popularized these days. Next, please. Yeah, these are all cost effective. All these we have already. Next, please. One important, just go back, please. one important thing is it needs training, but even if there is an unskilled labor also, they can be accommodated in this kind of system. So the system is so established that it is easy to adapt. Next, please. Next, please. There are some limitations. Any concealed services, if they are there, it's very small thickness, therefore it becomes a bit difficult. So that they are working out. The concept of concealing has now has become revealing in this case. So probably you may have to use some other kind of thing. That is one disadvantage, because in that thinner thickness, because walls and all those are of thin thickness. Therefore, that is one big disadvantage I could see. Next, please. Building information models we have already discussed. Next, please. Future projections involve the integration of artificial intelligence. Yeah. Sreenivas, can I have another 5 to 10 minutes time?
Yes, sir. Yes, sir.
Yeah, please. Because the main important point I wanted to focus on
Relocation, sir.
relocation.
Relocation of
Yeah.
building.
So use of robots for various works is expected. Widespread adoption of net zero concepts will come. And researching and documenting and then altering our technologies, that should be done. Interdisciplinary approach, like let us adopt AI and ML and all those. They are only tools. They have become, see, these days people are after them, but they are only allied tools. They are not the core areas. So let us adopt them. That is future projection, I can say. Next, please. Now, structural relocation. We'll talk of this. And yeah. Why could people think of relocating a structure? There could be several reasons, right? I have heard of some incidents that, a building is constructed across the road. Some gunda occupies this across the road. Okay. But then it has got to be shifted. But the building is very sentimental to that fellow. That could be the reason. Or let us say an employee got a transfer, but he could not leave because with so much of passion he could construct his house. He doesn't want to leave that. Now think of such situations. Another thing is historical structures. Probably when in Srishailam submergence, many temples were shifted. Temples of those days, they were constructed in stones. So stones can be disassembled and assembled. See the concept. Whereas this concrete kind of thing, it's very difficult to disassemble it. And even if you disassemble it, a lot of damage will be there, wastage will be there. So in that context now, structural relocation, how we will think, let us go through. Next, please. See, yeah, activity of a mine sometimes could also pose threat, and therefore shifting of buildings may be necessary. Next, please. Yeah, aspects to be considered are structural safety and risk involved, distance and time to be traveled, and therefore when a lot of distance is to be covered, along which roads, therefore permissions are to be taken, travel permits, insurance, etc. Size of the structure is one thing, its weight also is one thing, and available technical assistance or any other type of assistance. Cost of relocation, at what cost? Sometimes, if two persons are there, they got mutual transfer. If relocation is costing them their lifelong earnings, it is better to swap their houses, isn't it? So cost also is an important parameter. Next, please. This is a jail, a jail building, which was relocated in North America long back, and they used horses and mules and such kind of animals, to pull. This was mounted on rollers, wheels, and it was relocated. Next, please. So it was a Lubomirski Palace in Warsaw. In 1970, it has happened in Poland. And 8,000 tons weight it was there. And they were needing jacks to lift the weight. So it took about, the whole operation took about 49 days. And the interesting thing is relocation in an angular way. Next, please. Yeah, you could see that. See? So the building was originally here. It was tilted by about some degrees, right? So relocation could be in a horizontal plane. Angular relocation also could be there, right? Next, please. Like that, here is a chronological order of relocations taken up in various countries is given. Probably you can go through, right? And another, go to one, switching over, Sreenivas. Yeah, next. The latest record we have here is, next please, next 1999. So all these buildings you can see. Yeah, 2011-12. But a building is located well below the road level. It can be lifted up. That is also a relocation kind of thing. Although it doesn't fully agree with this definition, but that is also. In Nagol and other areas, this kind of thing was taken up. And relocation, structural relocation has become the career for many civil engineers, even non-civil engineers also for that matter, because mostly planning and lifting the building where the jacks are to be kept, and after that lifting it up and placing on a wheeled vehicle. So all this is to be planned and designed. So people who are thorough with these kind of things, although they are non-civil engineers, they have been doing this. Many such companies are existing in relocation, structural relocation companies are there in Hyderabad also. They are taking up larger projects. So, but my point is, building construction and structural relocation, building relocation must be affordable to a common man. If you see the prehistoric era, ropes, levers, and manpower, huge manpower used to be there, was used. Larger structures, wooden sledges and rollers were used, and possibly by animal power also was used. So, next please. This is prehistoric. And in the historic era, sledges and ramps were constructed. Egyptian pyramids, how they have taken up those stones up the heights. Even in Hindu temples, for that matter, Tanjavur temple, if you see the top piece, the shikara. The shikara weighs a lot of tons, but still it was taken up to that height. You know how that was taken up? So they used to lay ramps with sand sometimes, So those kind of techniques they used to adopt, and oxen, bulls, wooden beams were used to lift the loads. Hydraulic jacks, rail systems, and specialized jacks have come now. So all these are the relocation historic era. Next, please. In the modern era, prefabricated and modular constructions. So what they do? Earlier you have seen prefabricated pieces will be there. So unlike the concrete poured continuously, that is one of the disadvantages of the Maiwan construction, please. You cannot relocate that building. So you must decide now what is to be used. If relocation is to be done, then precast concrete construction, modular construction we call it. Why can't these modular constructions these days are preparing, you can see in IIT Hyderabad campus, very big sized elements. For slabs also big sized elements are kept one beside the other, and they are some aerosol kind of materials that is used for bonding them, and therefore disassembling also it becomes easy. Not much of damage will be there. So these elements can be again mounted on some vehicles and transported, although they are huge weights. Instead of lifting the entire building, precast concrete modular constructions can be used. But then I thought, why can't these modular constructions can be tailored out, customized to suit a common man? Like 3D printing technique also we will take. Instead of that bigger sized, some 3 meters by 1 meter kind of specimens will be there in precast concrete. Why? Let us reduce that to some 1 meter by 1 meter or even less, 0.5 meters by 0.5 meters. So all panels will come. These days, even retaining walls of bridges are being constructed that way. So smaller sized modules will be available, shall be made available in the market, and a common man shall go to the market. After he earns the required amount, shall go to the market to suit his plan. He must bring those kind of pieces in a vehicle along with him and start assembling them. Assembling also must become such simple, including the foundations. Mind you, the prefabricated constructions and all that, foundations and columns and up to the plinth level, they will bring in the normal traditional way. Later on, they will place these walls and all that, slabs. But even foundations can be moduled. Plinth beams can be moduled. Everything can be made into, tailored out into a modular construction. Why not? Only thing is, so this thing, with this thinking, what I tried, next please. I took a plan. I made my students work on this. I analyzed and I made a comparison, next please. For this kind of building, one is prefabricated and the other one is modular construction with smaller modules. So when I did this, another one is traditional construction, not prefabricated. So 3 I have compared. Next, please. See the loads on corner columns, intermediate columns, internal columns. Then when I have checked, they are comparable. And if I can prepare a footing module to take up this load, and if I can prepare, if I can think of a mechanism on which a column fits into this. These days, anchoring technologies have come, I said. So it is just assembling them, including the footing modules also. Why can't we do this? We thought of and we just analyzed. Next, please. So how many lifting mechanisms are required? Also, we have compared 4 numbers of 12-ton capacity for interior, 2 internal interior columns, and then 18 numbers of 15-ton capacity, 8 numbers of 10-ton capacity. Like that, the lifting capacities we have estimated. Next, please. Jacks. Lifting efforts for prefabricated houses were much lesser than a traditional house, but there will be additional efforts in handling and transporting the prefabricated unit. That is, however, required. Next, please. Whereas for the smaller module house, hardly a few trucks, to just couple of trucks to transport all of them at once. This was needed. So why can't we think of smaller modules which are available in market in the years to come? In future, a common man should go, whenever he thinks of building a house, should go to the market, bring all the panels, assemble them. This kind of thing should come, is my dream. Next, please. So this is what? Traditional building, minimum under normal conditions. Now it is working out as 1,000 per square foot, whereas prefabricated house comes to about 500 per square foot. In the context of this building only, please. So thorough study is to be made again. So there is hardly any other cost involved than the transportation charges required for shifting the modular units. That's all for the third proposed unit. Next, please. So there is high risk involved in relocating a traditional building. The risk is considerably reduced in prefabricated houses with greater modules, greater sized modules. And there is hardly any risk involved in the case of relocation of houses adopting modular system as proposed in this work. Next, please. So the conclusion here is, let me just. The developments in the field of building construction and relocation are fast evolving. And in the light of these rapid developments, it is imperative that a common man can aspire in the near future for having his own dream house built in his choicest locality, just by buying the units in a market at affordable prices, enjoy the construction on his own by assembling the units, and will still have the freedom of relocating the entire house to a location of his choice whenever needed. So this is the kind of building construction and relocation that we have to dream of, so that the things become affordable to a common man also. Thank you all, and any questions, please. I would like to answer within my limitations.
Dear participants, please unmute yourself and ask the questions to sir. I think a few questions may be in chat box.
Okay, what we'll do is, Sreenivas, collect the questions in chat box.
Okay.
And pass them on to me so that I can send the answers to you and you can disseminate them.
Sir, good afternoon.
Yeah, please.
This is Narendra Gaud, sir, your student from CBIT, and now I am working in MBSR Engineering College.
Oh, great. Very good. Narendra, how are you?
Sir, fine, sir.
Please.
So, in one of the slides, I saw that there is a linkage between the materials to the spiritual. So,
how?
I wanted to have some information on that.
Yeah. I'll throw light on that,
Yes, sir, please.
See, the father of concrete technology, who is it? Neville. He wrote a book also. Concrete technology book by Neville, a Britisher. Once he came to Hyderabad in an international conference. After the presentation of my paper, I have interacted with him. He was saying that the psychology of labor, unskilled, uneducated labor, is common everywhere. I was wondering whether it is the same there also. So once it seems he was talking to others standing on a slab, and they poured concrete, and his feet were buried in concrete. So that means the attitude of labor, it's not their fault. They are mostly unskilled and untrained in our scenario. They do not know what they are going to build, right? If they know what they are going to build is some Taj Mahal or some very big house, there will be some motivation in them, right? Another thing is, whatever work you take up, quality comes by a strong desire to excel. So, this is spirituality. If you dedicate yourself and do your work carefully, very cautiously, because people often blame us. One lawyer said, if I do mistakes, the people will be, hanged at certain height. But if you do mistakes, civil engineers, many people will be buried under your structures, he said. So if we don't mind that what we are building is of very great importance, it should be qualitative. Quality comes by a strong desire to excel. And whatever work is given to you, you dedicate, devote. That is spirituality. So material must be linked with spirituality. People often, thukna antaru vaadu ummistaru. Vaadu concreting చేసుకుంటూ పాన్ నవ్వులుకుంటూ ఉమ్మిస్తాడు మన దగ్గర. Kind of culture. అంటే అక్కడ ఏమన్నా రాళ్ళు ఉన్నా, ఇంకా బిగ్ సైడ్ స్టోన్స్ ఉన్న వాడు తీసేయడు, కట్టె పుల్లలన్నా తీసేయడు. సో మెటీరియల్ కి కనుక మనం స్పిరిచువాలిటీ జోడిస్తే quality will come on its own. Is the kind of thing. Narendra.
Yes, sir. Thank you very much, sir. Thanks a lot.
God's grace.
Sir,
Right, next.
One question is there from GVV Satyanarayan, sir. Is there any trade name for self-healing steels?
It is there. Right now, I am not getting reminded, but I'll send it. Okay. Self-healing steels are there. I will send the trade name to you. Satyanarayan Garu will be in touch.
Okay.
I'll give you.
You highlighted this Mivan technology, sir. So this is aluminum, you said, no, sir?
Yeah.
So aluminum, will it able to withstand the loads, sir, which are coming on the structure?
Yes, yes. See, it depends on what area you are paneling it out. So stiffeners will be there again.
So price of this aluminum formwork compared to our steel MS, how much, sir? Is there any comparison between?
It is costly.
Okay.
It is costly that way. That's why initial cost, formwork wise, it is costly. But the thing is, time it saves is a lot.
Okay.
So that is great.
So you said that your students are carrying out these works at Chautupal.
Yeah, yeah.
So can we visit their site, sir, along with our students?
Absolutely, absolutely.
Okay, okay. Thank you.
Yeah, yeah. He is a 92 batch student. I
Okay.
can talk to him and arrange this kind of visit. for him.
Okay, okay. Any more questions, please?
thank you, sir.
Participants.
Any more questions?
I couldn't get that. Any question was it or?
No, sir.
Okay. Okay. Thank you all for giving the opportunity to meet you all and interact. And special thanks to our Sreenivas and Raju and GRIET. Okay.
Yeah, thank you very much, sir. In spite of your busy schedule, you spent your valuable time.
Thank you, sir. Thank you, sir. Sreenivas, sir,
Right.
thank you,
And,
sir.
Right, sir. Right.
You highlighted a few points about the emerging materials, sustainable construction, and how the development of construction of building taken place, and precast construction, 3D printing, green building technologies, smart building systems, MIVAN technology, and how to relocate the building. So very, very interesting topic, sir. So you highlighted very well. So thank you very much, sir.
Thank you. All the
Okay,
best.
sir.
Thank you, sir. Thank you, sir.
So
Right,
dear
right.
participants, kindly join for tomorrow's session. Tomorrow will be the last session. So join at 2:50 p.m. sharp. Thank you all.
Srinivas, can I take leave?
Okay, sir. Thank you very
Okay,
much.
sir.